so you can hear me. I'll walk to you closer. Does that work? Because I like to float around anyway. I may end up right next to you. Not singling you out, but anybody in here, I might be doing that anyway. My name's Chad McVicker. I've been health and safety for 19, 20 years roughly. I'm with Safety Resource Company of Ohio. A little bit about us: we do a lot of trainings, pretty much multiple trainings. We do field audits. We do confined space rescue. We pretty much have our hands in just about everything. And I was told to ask this, but I don't know if it's anybody in here. Did anybody take a class at Akron U with Kurt Speck? See, I was told to ask the group, a safety class. Wait till I see him. I'm going to be like, hey, there wasn't anybody in there that took your class. So we'll do a little electrical safety and some distracted driving. First thing is, do we have any electricians in here? I know you're engineers. Do we have any electricians in here? No? When I ask this next thing, see who raises their hand, because I will too. We have at-home electricians. Oh yeah. An at-home electrician doing an outlet, things like that. I'm assuming nobody is going to be in their breaker box other than to do what? Flip a breaker, right? Oh, you're in there wiring and doing all that stuff? Well, you're an electrician then. What'd you do?
Replaced the box.
Replaced it? Did you upgrade your service and that stuff?
No,
No, just an older box. Yeah,
New box, new breakers.
whole new thing. There you go. A lot of people, electricity, it's a frightful thing. It is true. It really is. Myself, outlets go down, flip a breaker. What's one thing that most people do? You have a storm and you trip a breaker, not even a storm, but you got several different things going, running, and a breaker trips. Has everybody had to deal with that at one point in time? So when you go downstairs, right? I'm assuming that's where they're probably at. You go downstairs, wherever the box would be. Very first thing you do, right? Open the door up, stand there, see which one it is, and flip it, right? Reset it. One thing that we don't think about is when you do that, statistically, when you go to that box, we don't think, right? Because we're not electricians. We only hear stories of, oh, electrical, we get electrocuted, things like that. You wouldn't think that by opening up a panel door that anything can happen, but it can. A lot of times, there's been instances where you go to the box, you open it up, just to reset a breaker, and what's happened? It's arced. Residentially, non-electricians, just in the home, open a panel door and arc. More than likely, probability over 90%, probably death. Arc flash is extremely, extremely bad. And the one thing that's bad about that is, when you're dealing with heavy in plants and you're dealing with 480, whatnot, there has to be repairs done. Usually you're going to have the correct PP, right? You're going to have the suit, the specific gloves when you're dealing with that type of electrical. That's usually in your big businesses, construction sites, manufacturing. Construction sites as far as a new construction build for a new facility. Mostly manufacturing plants, steel mills, things like that. So there's specific PPE that the electricians would wear in a situation dealing with that. Some that aren't electricians, they'll go in, they'll be told, hey, just do this real quick. 480 is bad, okay? That's basically, in a sense, you're going to be dust, okay? It's true, right? A large amount of electricity like that, it arcs, it's bad. It's bad. A couple things, I just kind of wanted to throw that stuff in. Your handout, you have electrical safety. I'm not going to really read from this, but I want you guys to kind of, kind of skim through that a little bit and just try to take out little specifics as we talk. You kind of see it kind of makes sense, but we'll go ahead and get started here. This one here, okay, about 5 workers are electrocuted every week. 5. Okay, so think about it. 5 workers electrocuted every week. We work every day, right? So think about that across, we're just going to say the U.S. Is that a lot? You guys got to participate here with me. I'm all mic'd up, feel like a coach. I got 2 mics on. People are watching me. You guys are right here. You guys participate because I can see you. That'll help. That'll help. How's this going? Huh? I had to speak up a little bit, right? Okay. Glad you gave me the thumbs up. You're my man back there. Okay. All right, so causes 12% of young worker workplace deaths. 12% takes very little electricity to cause harm, right? Even an outlet. If you have heart conditions, okay? Believe me, it doesn't take much. It doesn't take much to get an electrocution. Is there a difference between electrocution and a shock? Right? Absolutely. Static electricity. You ever get that shock and you're, you move your hand back. You're walking in your house, right? Apartment, whatever. You go to touch something, get shocked, right? Static electricity. It is a form of electricity, without a doubt. Significant causes are fires, and we'll kind of go through that. But if you come up here and it says causes 12% of young workers' workplace deaths. Now we're going to kind of throw that in with, we'll use you, and pretty much what this is construction sites, right? 12% young workers, deaths. Why do you think that? Remember, it's participation. Somebody throws something out, even if you're wrong, doesn't matter. Did you hear that? Lack of experience, right? Got some young guys, right? They were in the trades, say they were electrician, they're an apprentice. They come on a job site. What's one thing? A journeyman, I'm using a union example, would say to an apprentice, hey, go over there and flip that. Hey, go over there and do that, right? So what happens? He knows minimal about it, right? He doesn't know everything. He only knows the basics at that point of what he's been taught. Experience, a journeyman, whoever, electrician for 20 some years, whatever. He's too busy, right? We hear that. Oh, I'm too busy. He goes and he gets into a box or does something that he shouldn't do. Gets electrocuted. Fatality. Potential, right? So you wouldn't think 12% is a lot, or you would have a different guy who's just maybe not an electrician, different trade. He don't know anything about it, right? Power tools, cords. Okay, there's a lot of stuff other than breakers, okay? 4 main types. Okay, we all know electrocution. It's death to a shock, okay? The shock and the burns, indirect falls. Indirect falls could be what? You're on a ladder, right? That guy could be the guy on a ladder. He's going up. He's just changing a light bulb, believe it or not. The socket, okay? It could jump from the socket. You're on a ladder. You're up like this. Even if you don't get electrocuted, you just get a quick shock. What could happen? Going to fall back, right? Absolutely. And you didn't even get electrocuted. You just got a little zap, and there you go. You fell. Fatality, because he got shocked. Wasn't a lot to get electrocuted, but enough to lose your balance. You're on a step ladder. Doesn't take much when you fall, okay, for fatality. Burns. Horrible. Horrible, horrible. Has anybody ever been, you don't have to answer, been burned by electricity? Raise your hand. My electrician over here. Is power off? Oh no! Oh no! You're brave, but it's fixed. It works, right? There you go. Burns are extremely, extremely bad. Obviously, it's received when electrical current passes through the body, right? So when I get to this slide here, it's got to have a path, the amount of current flowing, and it's always in amps and the duration. Low voltage does not mean a low hazard, right? Remember when I kind of said all about an outlet or whatnot? Doesn't take much. Here, example, standing on a metal or on a steel beam, okay? Grounded, simple, right? Goes up, he touches a wire that's live, it's non-insulated. Electrocution, one thing about it, when you touch that, you get electrocuted, it travels through the body. Why does it travel through the body? Path of least resistance and yes. That's my man. Back there, that's my man, I'm telling you. So yeah, and one thing about it is when it passes through the body, it's always got to have somewhere come out of the body, right? It's always got to, it's going to move somewhere else, okay? So what can happen is when it usually will travel through the body, it's always going to come out of leg, the other arm, fingers, toes, and when it exits, what do you think that's like? Pretty bad, right? Pretty bad. So you really got to be careful, okay? In this picture, it shows, I mean, none of us are going to grab a live wire. I hope not, okay? But just to give you that example. Okay, here, current above 10 milliamp can paralyze or freeze the muscle. That's not a lot, okay? That would be more or less around outlet, maybe. Currents more than 75 can cause a rapid, ineffective heartbeat. Death in a few minutes unless a defibrillator is used. Now, here's the thing. We think of electricity and we see a defibrillator, right? It's electricity, right? To jump your heart again, right? That's contained electricity, okay? It's not like a live line or something that's an open circuit, okay? So it can also help us, obviously, all right? Now here we go, 75 milliamp is not much current. A small power drill uses 30 times more. So any corded power tool, that's pretty much what it is here. Does that seem like a lot? Kind of really didn't think about it. Here's a burn. Immediate attention. You guys see it kind of good? I don't know if it's kind of fuzzy up here. Let me see. Let me come back here. Oh, good enough so we can see it, right? Lucky. Okay, very lucky. A lot of times burns like that, especially from electricity, you definitely have to, depending on how bad it is, usually a second, third degree burn, okay? That's got to be debrided, okay? Does anybody know anyone or yourself, and not anyone, you don't have to answer, does anybody had an experience or knows somebody that's happened to a major burn, had to have it debrided? You have? You can share if you want. If you don't, that's fine. No? What's that? Oh my. Yeah. Sure, sure. You say that one more time, just so I have to repeat that. The person died? Oh my. Oh my. Was it was it the burns? Was it from electricity or no? What? Touched a wire, wasn't properly grounded, and it was open. There was no like insulation over it. Oh my. Burns are extremely, extremely horrible. The debriding that I was telling you about, you know, you got to go, depending on how the percentage of your body, you have to go to like a burn unit. That is extremely horrible. They have to basically wire brush that off until new tissue starts to come back. So it's extremely, extremely horrible. Okay, here we talked about, remember I talked about falls, right? The guy on the ladder, junction box, he's up there wiring, right? Potential getting a shock, electrocution, fall off the ladder, okay? That's one of the most serious ones. And here, once again, I don't know if you can see it or not. But right here, that is a mess, right? We've got a lot of extension cords. It looks like we've got Romex that's wired somewhere up here and it comes down and everything's kind of tied in together. We got electrical tape and everything, and hard to tell what's going on there unless we were actually there to see it. But obviously, if we look at that, we know that it's not good, right? Here we go. 2 out of 3 are bad. Would you agree with that? Obviously, that's the good one, right? This one here's got the electrical tape, and here's wires exposed. Okay? I know when I go out and I do job site inspections, when I go and I look and I see electrical, if I see something that's like this, the first thing I do is I'm going to unplug it and I'm going to cut it. And then I'm going to throw it in the trash. I've actually had contractor, foremen, superintendents, supervisors get extremely mad at me and say, why did you cut my cord? Well, come on, let me show you how bad it is. So I've had that situation as well. This here, obviously, if we've got electrical tape over, we know, right, that there's probably been wires exposed. So we're trying to protect it. I've had people say, well, can you use electrical tape? You can if on a cord, the outside insulated jacket, if it's got, a little nick, a little tear into it, but in the jacket, not to the actual wires. You can use that as a protectant, okay? Unless a junction box, you're using it to tape around. I'm losing my train of thought. We'll come back to what I was saying with that. I'll remember here in a few minutes. Here we go again with this. Wires exposed, okay? And if a cord like this, it needs to be, the junction box and your wire nuts. Right? A little bit extra duct or a little bit of electrical tape. All right. So we see this here. It's damaged. Now, can a contractor, or say you're not an electrician, but you see it's bad, you unplug it, and you're going to tape it up. Or you tape it up, which you can't with the wires, but you take the cord out, I'm going to put a new plug on it. You cut it. Maybe you do a fantastic job of rewiring it and putting it on. Per OSHA, can you do that if you're not an electrician? No. I've had people ask me, well, can you repair a cord if it's like this? You can cut it if it's an electrician and they can repair this. Okay? Personally, I look at it like this. Get a new cord, right? Why take the time to go ahead and do that? It makes no sense. Here we go again. We've got this box, junction box. You can see it's open. Obviously, it's hot because you can see that probably over here are all the wire nuts, and they've taped the heck out of it to go over top of them. So that's not very good as well. Here we go. Some more. I mean, we've got Romex everywhere, and look, they've even got tape on it to identify what's running where and everything like that. But you see this coming up out of here. We've got that. It's extremely, extremely bad. Use barriers, right? Guard your live parts. Okay, operating 50 volts or more against an accidental contact, right? So you got to be careful. You've got a screwdriver in there and you're trying to tighten something up and it's non-conductive tool. There's a potential something bad's going to happen. And you can see here where it's pulled in. We've got electrical tape in there. Here we go. This is what I was talking about. These wires are exposed coming out of the Romex. Now, what could they have done? Not cut it back so far, right? Or they actually could have used tape. They can around this wire nut. But this Romex is cut back way too far, okay? Cabinets, boxes, fittings, these knockouts. I see this a lot on these boxes, on switches or little junction boxes. These knockouts here. Those are out, you run wire through it, okay? And it's exposed. Okay, that's exposed wire. You can't have that either. Okay, which there's the junction box, one opening. Here's another junction box. You can see that it doesn't have the cover on it, but obviously I don't know if that's I don't know. We've got a lot of issues right here. That's open. It looks to me like I can't tell what's on that. That you would spray in the ceilings. Yeah, fireproofing that they use when they spray inside, usually on the steel before they close in the ceilings. They'll spray the fireproofing on there. Here we go. That's a wreck, isn't it? Now, no, I would say they're not, right? But if you would come in here, it's hard to read this once again. It's cardboard, and it says danger, hot. Cardboard. Now, they've identified it, right? So even though they're pulling these wires and, you know, everything here may not be the potential, but we don't know, right? But obviously something's hot because we have a piece of cardboard up here to identify it. Fire, right? I don't think we could do that. Here we go. Piece of wood. Look, he's got it shimmed up through there. Oh, you couldn't believe some of the stuff that I've seen on job sites. We're going to make it work. It'll be okay. That's not good, right? Here we go. Danger, 480 volt. Stay out. Well, panel's door isn't on, okay? Panel door has to be on if it's exposed and it's actually hot. But we got cardboard again. Danger, stay out. Now, if you made this little sign, because obviously we probably got breakers in here that are open, or they haven't actually put them in yet. One thing that you still need to do is you actually need to put the panel back on over top of this. The reason why they don't do it is because why? We got to take all the screws off, then we got to put it on, we got to do this. You can't identify like that. Garbage. Sitting right here, right? This isn't identified. Okay, so maybe it's hot, maybe it's not. Maybe it's hot, maybe it's not. Right? So we have cardboard here. So if we would have a spark, now we have a fire, correct? Here we go. We've got this Baker scaffold pushed up against here pretty close, right? That's metal, conductive, no panel on it. Now, it's a lot of times it's, well, I know, everybody here knows that it's hot. They saw me wiring and bringing stuff over here. Everybody here on the job, they've been here forever. You know, we're trying to finish this building up. Everybody knows. Maybe not everybody does because people come and go, right? You're going on a different job. We're taking this guy. And regardless of that, you've got to do what you got to do to make that safe. Okay? Definitely an arc off of that. Now, usually non-insulated, which you obviously can see here, these power lines. Okay? Some things that could strike it right here. Okay? I've seen dump trucks hit those before. I've actually got some videos on it. I'm not going to show them because of time, but maybe another time when I come back, I'll start right into that. If you guys can remember that I was talking about it. Dump trucks, putting the bed back and hitting that. Okay, cranes, whenever you're doing work next to any kind of live power line, 50 kV, you have to be 10 foot away from that power line. Okay? Stay at least 10 foot. There it is. Now, we all know we don't use a metal ladder, right? We're going to set a metal ladder up, and we're going to go and we're going to put a new light bulb in. It's just a light bulb, right? We're not going to do that, right? Nobody in here is going to do that. Here's our gauge. We can check what wiring type we have when we have to do some wiring. This is very, very good to use. Some folks don't. They don't use it. They'll, you know, you could take a different gauge wire. It kind of looks the same wired up. That could be a definitely problem, right? All right, this is a question for everybody. What's wrong here? Oh, who said that? Oh, it wasn't my man. My other man back there. Okay, I love it. Right, we got a tripping hazard. What else do we have since this is electrical safety meeting? We've got this homemade device plugged into here. It's metal, there's no ground. We've got this here that could get cut, stepped on. This looks like it's going to one of the, this is supplied gas line, going to one of the temporary big torpedo industrial style for heat. So we definitely have a gas line here. Okay, we have all this here. This is some kind of homemade device. And then we got our regular fan here, which is not even supposed to be on any kind of a commercial job site. That's for the house. It's on a job, quick story. I don't know what kind of time we have. Where are we at with time? What time is it? Cool, cool. We got it. Who said that? My man again? Hey, just give me a thumbs up and we're at about another 5. Sure. With the red plate? This, I believe, is some type of a heater system. Okay, and what I'm assuming they're doing is they're taking this and they're setting it on top of here to produce heat for that. Once again, can't do it. I've seen it done. Okay. I was on a job where, commercial job, they were redoing, it was Slippery Rock University, and there was one science building or something they were doing an ad-on. And I go around the one side door and I'm walking through, and there's all kind of construction going on, and I go over to where I see electrical at, and I see power tools and stuff, and you know, usually they're hooked into GFCIs and all that like they're supposed to be, and I walk around the corner and I stop. Surge protectors, the ones we keep at the house, right? For the computer, TVs, all that good stuff, right? We all have one or know about it. I think we all probably have it. Sitting there with cords plugged into it. Now, a couple things. You can't have that on a construction site, but do you think when you're plugging drills and power tools in it, is it probably going to continuously trip? Probably. So, number one, you can't use that. And number two is, who's the guy that's going to keep going over there and resetting it? What, you just get a regular commercial style GFCI, right? Just kind of it's kind of funny to me. I don't know. 3-wire type. Okay. Extra hard wire insulation on these. And how you can tell is you can look at the type over here. Okay. And pretty much you can identify those. We all know what a regular at the house extension cord looks like, right? Versus one of these. Type SO. Here we go. Wow. What do we have going on here? We have a little bit of water. We've got some plastic. We got some wood, rag. We got a little, geez, we got a little heater here. We got a little donut pack. Powdered donuts too. Huh. Paper. Look at this, running through this. This is a fire hazard nightmare. Who would do this? I have no idea. But obviously, it's done, right? Defective cords, once again, that kind of took us in the beginning there. Well, about mid slides right here. Up here, you can see it's taped, and we've probably got cords that are all screwed up. Here, this looks like it's been a little charred, it looks like. One reason is probably why. Simple. Why? Close. No ground pin, right? I see a lot of times too the ground pins. Why? They snap them off because it's easier to go into a tool to plug it in, right? Because some power tools don't have, believe it or not, the older ones have where the ground pin could connect. or into something else as far as plugging it in wherever on the job or whatever. So with no ground pin, this is what can happen, right? Cause a little small arc, melts it, could be bad. If that cord's laying in water, right? And somebody's in the area and they're standing in just a little bit of standing water, what can happen to them, right? If that cord, okay, is maybe plugged in on the floor off of that outlet, and we've got some debris on the floor, poor housekeeping, what happens? Another thing too that I see a lot, and I'm sure that we've all done this at one point, maybe, on a lot of construction sites, I see a lot of cords pulled through doorways, or the door is laying up against the insulation. So guys will come in, and it'll come back and it'll hit it. It'll come back and it'll hit it, right? So what starts to happen? The insulation rubs, right? Or it gets pinched. Here we go. Damaged cord. Let's plug into this scissor lift to charge it. See that there? You guys know what that is? Little screw in the tire, metal, right? So if we have a bad cord, or the cord that comes off of the scissor lift that hangs down, it could plug into there. Let's say, oh, well, he backed it up and went under the tire. Is there a possibility that that could happen? Yes. Okay. Slim, but we don't want to say, well, it might happen, it may not happen. Insulated, okay. Obviously right here, these wires are not insulated. If you're going to cut the insulation off because you have to tie this in, okay, then you need to make sure that when you tied it in that none of this has any exposure, okay? So a lot of times it's pulling the insulation, the jacket as they call it. Sometimes they cut it back too far, right? And you don't need to. So you have exposed wires. You cannot have exposed wires that are hot. Here we go. Here's that ground pin. You can see how it's got a little arc and caught fire and melted the plug. You don't want to use flexible wiring, okay? You can see how it's stationary equipment to facilitate, okay, interchange, running through holes, walls, ceilings, floors, things like that. Is it okay? So it looks like they threw it over there and the jacket is rubbing, and this might be duct tape. Maybe to kind of help because it's worn on there before, or sometimes we'll put it on there, I lay it over right, it's going to help that insulation. Grounding creates a low resistance path from a tool to the earth to disperse unwanted current. You guys can see exactly what's going on here, right? Short lighting occurs, energy flows to the ground, protecting you from electrical shock, injury, and death. Once again, ground, not plugged into a GFCI. Over here, what's this again? Remember I talked about that? The knockout is missing. More of cords. There we go. How about that? How about this? Obviously, it's hot because I'm assuming this Romex, we can't really see obviously all the way up here, but I am pretty much assuming that we have an issue here, right? Looks like we've got a little bit of water. This has to be pulled up 7 feet above. If it's hot and it's actually been wired correctly. None of this has to be up off the floor. It has to be uniformed. It can't be just a thrown together type thing. Okay, if a cord, Romex, temporary lighting, if it's hanging down to where it's in your path, okay, you could hit it. You're carrying something that's conductive, 7 feet or higher above you, okay? Making sure that any tools that are corded, okay, they have to be a grounded tool, insulated handles. Here's the difference between that. We see these where? In your bathroom. That's the construction one I was telling you about. That's higher for the reset, right? That you need to use. Not like the surge protector that I saw. You know, you don't want to do that. Here we go again. Too many plugs, too many devices, okay? It can cause heated wires, possibly a fire. Would you say absolutely? Because all this is a temporary box. It's probably plywood, a piece of wood with, you know, 4x4, 2x4, whatnot, you know, pushed into the ground. Here's some more. And this one, here's Visqueen. So I'm assuming it's winter time. So what they're doing is they want to be inside to hook up any of their stuff while they're on a scaffold, so they don't have to go outside. Way too much plugged in. We've got open circuits. We've got duct tape there. We got the Visqueen, right? It's pretty close. We got a lot of freaking issues going on here. Fuses, circuit breakers. Fuses can melt. Circuit breakers trip open. This here, this is pretty nice. This is really nice here. That's all uniformed in the right way. Cover plates, no cover plate. We've all seen this. I've done it when I've been, you know, putting new electrical in. Cords, ground pins again. You know, you got a ground pin hanging out. You don't have a cover plate on it. This has probably been new drywall. You know, here's another thing here. Assuming temporary lighting. I was telling you guys about that. I see this a lot when I go into facilities as well. I see these cages with no bulb in them. So let's say we have stringer, okay, up above, temporary lighting. And we've got all the bulbs, then we have a missing one, okay? Then we got a few more of the bulbs, then we have a missing one. So the cage is fine if there's no bulb. Is that still not compliant, even though the cage is over it? Not compliant because the socket's open. Well, there's a guard over it. Doesn't matter. It's still a live socket. Got to have a bulb replaced in it. Now, I've seen too where the cages are open and you've got an exposed bulb. Okay. Obviously, that's not going to work either. The protective cage has to be shut. I see that a lot when I go out on my inspections. A lot of electricians do that. Not necessarily it's their fault. Usually it's another trade, you know, carrying a piece of equipment, a tool, and they bump it. They don't say anything. It happens. Here's what I was talking about hanging down, going up the temp lighting, okay? Come around a corner, you're going to hit that. Has to be pulled up. There's just another insulated jacket. There we go. See this cord? You can see that hanging out of it. That's another bad picture. After you de-energize, if you have to lock out, you got to have a lock, okay? And have it in the off position. Got to have signs, okay? A lot of times we'll see those in big substations or not, you know, whatnot. Danger high voltage, right? We look at that, we all know it. But believe it or not, you still legally you have to have it posted, have a sign, right? Signs are a wonderful thing because a lot of times placards, you go up and see it. Maybe you don't know what the chemical is in that truck going down the road, that tanker. But if we see something with flames, we know, okay, that's gas, right? So it's good identification. But that would be for HAZCOM. I don't know when we're going to do that. Here, you can see this is an old wire, right? An old wire. We've got some water. We've got rust. Those wires are exposed and they're pretty bad too. Water laying here by the moisture. PPE, proper foot, hard hat. There's in the slide, a couple slides prior to our reset, right? Too much overloaded, it's gonna kick out, then we have to reset it again. Some of the hazards, protective measures on each side is for our summary. We pretty much talked about inadequate wiring, overloaded circuits, power lines. Remember the power lines, 50 kV, 10 feet away. minimum. Our proper grounding, we talked about that, our breakers, grounded live parts, lockout tagouts. Lockout tagout's a big one too. When you lock out a box, you have to have a tag, lockout tagout. Has to be an approved tag, okay? Your name, phone number, who your company's with. I've seen hasps, okay, put on the lockout. Well, the hasps has got all the different, lockout locations because if we have so many locks, depending on the crews or whoever we have, we've got all these locks on there, right? At the end of the day, and that person doesn't take their key, they just left for the day, they forgot, okay? They took their key with them. Why is that tag there? To identify so we know, uh-oh, whose lock is this? Are they still in that piece of equipment? Are they still in that machine? You don't know, okay? Energized power source. Questions? I hope that I answered everything. Oh, one more thing real quick, and then we'll switch gears and I'll get to driving. I'm kind of running behind here. Water. Everybody says water, water and electricity, they don't mix, okay? What actually electrocutes you about water is there's minerals in water, right? There's minerals, there's metals, things like that. That's what can cause electrocution, okay? The liquid in its regular state, no. It's the metals, the salts, things like that. Salt plants, extremely flammable. Sugar plants, extremely flammable with electrical, okay? So makes sense, right? Metals and stuff in a solid, liquid, water. Good? See some yawners? I get it. So I did a good job. You guys happy? Hopefully the folks that can't see me, hopefully they think I did too. We might see some stuff coming in. Ugh. All right, we'll do driving. This isn't going to be, driving is pretty, that's why I waited to do it last. We'll kind of go through it. It won't be spending a lot of time. It's stuff that we all know, right? It's stuff that we always hear about. Text driving, don't do it. Driving skills, how good are you as a driver? How many bad drivers do we see every day? Tons, right? Tons. Car crash, employee and family member. Today's news, you always see something like that. Always in the news every day. Here we go. 16 people, they die. Work-related, 10,500 people are injured daily at work. 22% are vehicle-related. So at work, are you thinking you're driving your personal car through a facility? No, it could be what? A company vehicle, right? Highway deaths, 43,500 annually. This is from National Highway Traffic Administration. That's where a lot of these statistics are going to jump out at you. If you would look real quick at the bottom, did you know, and there's some actual stats, one from Carnegie Mellon, one from the Insurance Institute Highway Safety, and the bottom is University of Utah. These are all statistics that were conducted. So we see the highway deaths, motor vehicle deaths, 42,500 disabilitating injuries. You see the number here, right? Workplace. I mean, obviously, this is always an occurrence. This here, workplace, you would think, wow, really? And that's kind of what we said, right? About company vehicles, okay? Vietnam had 60,000 deaths. So if it had 60,000 deaths, start thinking of different statistics of numbers and everything, right? Just look at the disability injuries over there. Now, how could you calculate this in body weight in pounds, okay? So miles per hour, 5 miles per hour, right? Looking at 125 or 125, so on and so forth, 100, 157, 175, 225. We think Now let me move. The forces of the impact. So it kind of gives you an example of the speed, right? How about if we look here? 75. Crazy, huh? Awareness, 360 awareness. All around you, right, left, behind you, using all your mirrors, making sure that you look. 360 all the way around, okay? Living environment. You can see the 360, there you go. I didn't put this PowerPoint together, but hey. Sharing the road, pedestrians, right? They always say pedestrians have the right of way. That's what's said, no matter what, okay? You got to share the road with the bicyclers and the pedestrians. Bicycles, there we just had thrown that. Motorcycles are the other thing, right? Trucks, recreational, animals, right? Maybe we're driving okay, but it's unpredictable. That deer jumps out, whatever. Trains, right? We all know or have heard of people trying to beat the train. True. Wow. I can honestly say that I never have done that. But a lot of fatalities when they say, well, from a train, it's because of trying to try to beat the train. The train's going to win every time, right? Safe speed. Making sure you're doing the speed limit, okay? Because a higher speed limit, obviously, we know if we go back to the body weight and whatever, and a lot of traffic, or, we're not on the Autobahn in Germany, right? Where there's absolutely no speed limit. And that would be pretty cool, though, wouldn't it? Be on the Autobahn just once. Give me like the fastest car, exotic car, the fastest car ever. Let me get on the Autobahn just once. Let me just see, without crashing, of course, right? Primary crash causes, stop signs, runner. I think we've all in here ran stop signs, right? Or we do if we don't run it completely, have we done where we come up to the stop sign and just go, right? We're all guilty of it. We do it. But don't be a statistic. You see the numbers are up here. We've all heard about it, but statistically, here it is. Stoplight runners, right? Okay, I'm going, man, I hope I can beat it. I see it's yellow. I can go through. What happens? A lot of times we get through, right? We all do it. But this is stuff you don't stop and you don't think about it. Left of center. Left of center. Not only from alcohol, but from what? What's the biggest one? Texting. The biggest percentage of a lot of these car incidents, accidents, fatalities are because of that. That's one big contributing factor, okay? Road conditions, right? Snow, coming up to a construction site, rain. One thing that it's hard for me to understand, it's just me personally, is here in the great state of Ohio, what do we have? Rain, snow, ice, right? We've got to prepare for all of it. Now, I never could understand living in Ohio when wintertime comes that everybody forgets how to drive in the snow. Everybody agree with me in that? How do you forget? You just did it last year. Unless you had the winter we just had, and that was pretty good. But it happens. Clear distance. Who's got that person when you look in the mirror, it's right on you? And how many people here have done a little brake check on them? There you go. You want to get close to me? There you go, right? No matter what kind of hurry you're in, you're not in that big of a hurry if you're that person. Just keep a clear distance from them. Because what happens? Somebody ahead hits their brakes, the next one, it's a chain reaction, and then what happens? There's damage to the vehicle. Now you're looking at, insurance and turning into the shop. I mean, because everybody just wants to get too close. I always say this, driving today, everybody is in a hurry to go nowhere. Some people say, no, that's not true. I got to get to work. Well, we get to work early, and you won't have issues like that, right? Now things happen, but you guys get what I'm saying. Safety cushion, 3-second rule. There we go. Give yourself a 3-second rule, okay? Always think of that if you're trying to think of maintaining that distance. Here we go. Here's some have case of the gotta. Pick up, delivery, gotta go to the bank, pick up the boss, I gotta, get to the store, right? I don't know about this one. I'll pick up the boss if he needs me to, but it's not like I'm gonna make that an every day. Unless he's giving me gas money. Well, that's different every day then, right? Be on guard. Be a defensive driver. This is driving safety, but defensive driving and driving safety go hand in hand. Always be the defensive driver, okay? Always be watching. That guy is texting. That guy who is, where are we at, man? Past 1? Okay, I know you guys got to get back here. So you guys get it, right? Wherever we go wrong, we'll go wrong, okay? See no evil, hear no evil, speak no evil. Don't be naive. Road rage, right? We're closing it in here. We're closing in here. Bear with me. Road rage, see a lot of it, right? We've even been the one who probably might have a little road rage, right? That son of, and you floor it and you just, you give them the thing or what. You guys know what I'm talking about. Lane changes. Make sure you're not that guy, because I don't like it when I'm driving and this guy has to come around me and zip, zag, and go through. We've all done it. Think about it. Huh? That guy. Horns, beep, all that. Make sure you're the reaction time, okay? Use the horn when you need to. Don't wait till the end. Headlight flashers. When you're driving, you got that guy at night or whatever, and he's driving, brights are in your eyes, and then we always give him a little flash, and he knows to turn his off. Okay, this happens, okay? It does happen. Sometimes it helps you to tell that next person, hey, turn those off, okay? Tailgaters, we always have a lot of these too, right? Like I said, this is all common sense stuff. Driving safety is common sense stuff. But when we start talking about this, it triggers, right? Oh yeah, we don't think about it. Puncher, we've all seen that, right? Up on the steering wheel. Human factors debilitate you and can prevent you from making rational, accurate, safe decisions that you need to. 95% of all crashes are caused by human error, resulting in everything we just talked about, 95%, right? Injury, damage, fatalities. Anger, same with road rage, right? Hey, get out of the way, this and that, daydreaming. This is true. I'm trying to finish up, guys. Bear with me. We're almost there. How many people, and I've done it, how many people have driven from work to home and don't remember you left, and how the hell did you get home? Who does that? That's amazing. I've done. I'm like, man, I know I drove home. I don't remember how the hell I got here. Right? We've all done it. I don't know. It's just I don't know. We've all daydreamed. We've done that. One part of daydreaming. Distraction. How many people do this? Another thing we've all done. Oh man, there's a bad accident coming up there. Holy crap, we got 3 cars, 5 fire trucks. Oh, we got a car flipped over in a ditch. Oh, we got another one flipped over. We're going slow, so here's the crash, right? I'm driving. Huh? You're that rubbernecker. We all do it, right? You want to see what's going on. Don't do that, because you got somebody behind you. It impairs traffic and what the emergency services need to do their job, because you're rubbernecking. Frustration, fatigue's another thing. You're tired, you worked a lot, coming home from work. It could be something at work. You're up all night with your kid, was sick. You can be tired, physical, mental. Stress, right? Stress with the job, stress with stuff outside of work. We all have it. Stress fatigue syndrome, okay? Secondary crash causes, another human factor, okay? If we have stress fatigue syndrome, constant. Drugs and alcohol, obviously, right? Being impaired. Daydreamer, that's, I think all of these we've done at one time, and hopefully, definitely don't want to be there, okay? We don't want to be there. When can it happen? Anytime. We have no idea when this can happen, okay? Maybe we're a good driver, but it's the other guy, right? So we always got to have that 360, have that awareness. Driving talents, training experience. We've all seen the crash guy whenever they're, testing new vehicles and they smash the wall. And safety investment, your life, your spouses, your family, your friends, co-workers, a lot of people you depend on, a lot of people depend on you, especially family, okay? So be smart. Be smart when you're out there driving, okay? Search the web. These are some of what I told you guys about. Some of the agencies that are on your handout, if you want to go ahead and check those out. Your loved ones are waiting. We're done. Now I can take my head coaching wires off and everything because we're good. Thank you, guys. I appreciate it. All right.